from, actually Anthony wanted to discuss, had some concerns related to midterm. So probably now the plan for today would be the following. You talk anything you want to know or discuss related to midterm. Then I need to discuss lab 7 quickly, because you need deadlines and you need to know what's happening. And we need to introduce lab 8 and finish from it. So that's it for today. So your concerns related to the midterm, I'm ready to listen to this. Tell me.
Doctor, first thing, can we know the average, what it was with the raise and before the raise?
Okay, I can show you an informal document, but I would share with you what you want, if you want. Okay. So this is the file I'm looking for. My average, so I need to discuss 2 classes. I want you to focus on the yellow and the green. Your class is the yellow, okay? This is the average of the F. F means the without the raise. So without the raise, the average was 63. I think with the raise, it's gonna be 73 since we added 10 points. The reason why we added only 10 points, and if you can see my other section have 58. Okay, the reason why we added 10 points is we raised all the grades until we hit 100%. So we have many students, not one, who had 90. With 10%, they reached 100%. That's why we gave everybody 10% and not more and not less. That was our method. Raise everybody until we hit 100. Did I answer your question? Yes, any other question?
Doctor, my next question, it's not exactly, it doesn't exactly have to do with the grades as they are. But Anna, personally, I really felt like, considering what you told us, you know, just doing the lab reports is fine for the midterm. If we do the lab reports ourselves, which I've been doing, and I'm not even doing it in pairs. I'm doing the whole lab reports myself just to be sure about this. I just felt like the exam was on a whole different level than the lab reports. يعني ما حسيت أبداً level the questions at level lab report.
So you
and
think,
the thing is,
you think, Anthony, you were not ready for such questions?
Not at all. يعني it's fine if the midterm is slightly harder than the lab reports. It's normal. But at least in this case, I need to have something to prepare with, especially considering the course I've taken it 2 years ago in a different university before I transferred to LAU. So I really have no other source than our lectures, our lab reports, which I felt like were really on a easier level. I did them no problem, but I really struggled in the exam.
All right, by the way, I'm very surprised, Anthony, because this is the first time I hear such a comment. Usually the students were not happy with not being allowed to backtrack, not happy with the random questions. But a lot of students told me that they believe the questions were not difficult, and if they can repeat the midterm, they can do better. You are the first one to say that the midterm is a bit tough, and I'm surprised to see a lot of students agreeing with you on the chat, like Ramza, Rawan, Ryan, and Joe, and George Michael. They're saying that the midterm was tough. I remember, and I'm really happy to hear this because I didn't know, to be honest. I remember the capacitors experiment needed you to do a lot of data analysis that were tough. And can you please explain exactly, Anthony, where exactly you find it difficult? If the questions were actually targeting propagation of error, which was simple question, error on the slope, which is simple, and the conceptual questions that we had, some of them were tricky, but not really difficult. So I have some concerns here. And yes, Anthony, probably I can offer the class some random conceptual and data analysis question to practice with. And I do understand that probably you did the course long time ago. May I ask you, where were you for the course, and which department? I mean, in which university?
I was in AUB when I did it 2 years ago, spring 2018.
Yeah, and the content of the course is exactly the same.
Sorry.
Yeah, and the content of Physics 301, no, 305, with what AUB has, it's basically the same because I was there. So it's not like you missed on a lot. Probably you need to practice and you forgot a bit. But yes, I would really need to give you a push in a way. Anthony.
Yes, it's not a set different, but it's a set like 2 years, more than 2 years ago, يعني تقريبا. I really completely forgot everything.
I have a question for you, Anthony, because I really need to understand which questions you found difficult, like the conceptual challenge or the data analysis, because you know the midterm was a mix of conceptual and data analysis. Which one was more tough for you?
Conceptual, of course. Exact, I don't remember anymore exactly شو كانوا questions, بس بتذكر conceptual.
Can you remember a question that was tough on you, like some graph, sketch a graph?
I really forgot.
Okay, no problem. No problem.
But what I remember because of this I was tight on time. يعني ما كنت عم بعرف، كنت عم بعل كثير على الأسئلة. And this reflected even on my data analysis. يعني because I was late there was a data analysis that needs lots of calculation and I just skipped it. I couldn't really give it the time it needed. It all went wrong.
So I'm gonna say the timing was tough. The backtracking made it even more tough. And some students have conceptual weaknesses. And as I can see, you're not a few students, probably a big percentage of this section, and I never knew this. Can I ask you a general question, Anthony? May I say that you're okay with data analysis so I can focus with you on conceptual?
Yes, I'm okay. I've been doing it for a semester and last semester with you.
Okay, so conceptual was a little bit tough because you were not ready anyway, and you felt that the lab report did not make you ready enough for conceptual challenge. Yeah, probably you have a point. Probably you have a point because the lab reports are very rich in data analysis and not so rich in conceptual. Although I need to tell you that Physics 306 this semester, we added so many conceptual questions in the lab reports. If you compare them with the previous lab reports, the conceptual questions were basically not very existent. But anyway, you need practice, and thank you for telling me this. I had no idea. All right. Any other comments? Anyone would like to say anything else? Yes, Ramza, you wanted to
Yes, doctor.
Yeah.
Yes, أنا personally, I'm taking the course along with the lab, يعني in parallel.
Yes.
يعني very honestly, I حسيت إنه the midterm of the lab was even harder than the course.
Really?
Yes.
The course is tough though, you know?
It is tough. It is. بس honestly يعني we were expecting إنه يكون في أسئلة data analysis أكتر بكتير من conceptual. هلا however I don't have a problem with conceptual questions وخصوصا إنه I'm taking the course كمان this is an advantage علي مثل إنه عكس for example Anthony. بس حتى the conceptual questions أنا لقيت صعوبة فيهم صراحة. ويعني أنا usually I don't say إنه this exam was hard لأنه this is very relative بين شخص والتاني. بس I feel إنه the average of the two of both sections حتى the other sections it reflects إنه it was a hard exam.
Yes, I totally
usually
agree.
ما بقول هيك لأنه it is relative. ومثل ما قلت إنه في يمكن people that were able to get a 90.
Yeah.
However, the average itself إنه it's خصوصا إنه it's يعني lab ومنكون معودين على to work on reports أكتر و to expect questions that target data analysis أكتر. So إنه تأجى هيك إنه it was a bit surprising صراحة. وأنا هلأ مثلاً I'm concerned with the final لأنه أكيد إنه it's going to إنه حيجي تقريباً زي الشيء مثل الميدترم. يعني أول شيء كنت إنه مش حابة فكرة إنه بس يكون عنا final مثل last semester بسبرينغ. وأنا كنت أخذ اللاب تبع physics 1. So ما كنت حابة إنه يكون في بس فاينل، حابة إنه نشوف كيف بيجي الميد تيرم وعلى أساسه نعمل الفاينل تما يكون بس علامتنا بالفاينل. بس بالميد تيرم it was a bad experience صراحة، غير الفاينل. So أنا هلا I'm very concerned for the final honestly. ومثلا أنا personally مش حابة أعمل drop للكورس لأنه كتير عم بتعذب بالريبورتس وعم جيب عليهم كتير عالي which is very nice، وإنه عم بحط تعب وعم لاقي تعب. So ما يعني أبداً مش حابة إنه أعمل drop للكورس وأرجع أضطر أخده وأرجع أحط تعب على الريبورتس to focus عليهم. بس بذات الوقت مثلا أنا personally I got a very low grade on the midterm. It was surprising for me. So yeah, that's it.
All right, so I was talking to one of your friends a few days ago and I was like, do well in the final exam and let's try to cancel the midterm, lower the percentage as much as possible. Let's see what we can do. All right, now you know, and we know as well that probably we should be more flexible with the timing and with the backtracking, because if we give you more time, probably you can focus better and do so much better. And I don't know, for modifying the difficulty of the questions, I'm not sure we can do that, but probably with time you will be more ready for such an exam. I don't know if we can include a subjective part, but we had a bad experience last year with the subjective part because it's a lot of work as well, and you need to upload your work as well, and a lot of students did not have the time to finish the subjective part. So
yes, true.
So يمكن ما تكون حل anyway، يعني يمكن leave it MCQ as such but probably modify the way it was given. And أهم شيء بالنسبة لي me as an instructor, timing and backtracking has to be different.
Yes, true, I agree. يعني
sorry.
But I wanted to say إنه such courses يعني physics courses that require calculation أنا بقول إنه it's very يعني it's very unfair إنه ما يكون في backtracking. I agree مثلا يمكن بغير courses that are they're يعني الشغل تبعهم based على memorizing و understanding يمكن I understand إنه خلص واحد بيعمل سؤال بيحط الجواب وما رح يرجع يغيره بعدين. بس يعني questions that require calculation إنه مثلا مثل ما صار مع أنتوني أنا صار معي كمان ذات الشيء. كنت عم جرب ركز على الكونسبتوال لأنه for me إنه كانوا صعبين. So تبع الداتا analysis I didn't have the time إنه أقدر خلصهم أو أعملهم مثل ما لازم. So مثلا يمكن for example أنا لقيت سؤال conceptual كان صعب لإلي بقفي بروح على data analysis شيء أنا متعودة عليه عم بشتغل عليه بالريبورت I have the time إنه أعمله بعمله and then I go back to conceptual لأنه إنه بيكون برجع صار عندي وقت. So هيدا الادفانتج بالباك تراكينج. يعني أنا I understand إنه الجامعة يمكن إنه حتى رول إنه يمكن ما في باك تراكينج. I understand إنه الانستركتورز ما يحطوا ما يصير في cheating أو etc. بس مثلا هيك كورس أو هيك إكزام إنه ما رح يصير يعني حتى لو صار في cheating ما رح يفيد. يعني هن based على calculation أكتر وما رح يعني حتى لو كان open book ما رح نستفيد. مثل for example الكورس تبع الفيزيكس إحنا هلا open book وفي back tracking وستيل الواحد فيه ما يعمل منيح لأنه ما رح يفيد. So أكيد I agree with you إنه backtracking and timing it has to be reconsidered. وإنه as you said yes إنه يمكن إنه difficulty I know إنه it has to be an exam it has to be up to the level. بس بذات الوقت إنه يمكن for example بالثيري أو بالباكراوند تبع a certain experiment theoretical part قصدي إنه يمكن يكون في إنه to focus أكتر على theoretical part على conceptual ideas إنه نقدر نفكر beyond شو صار بالإكسبيرمنت لأنه الإكسبيرمنت itself it's being يعني عن جد think you're simplifying it very إنه it's very clear it's very simple وعم لقيه كتير simple والdata analysis كمان it's very clear it's easy we're enjoying إنه بالcalculations وهيك. بس تبقى الجاب أنا شخصياً كيف شايفتها الجاب هي بقصة كل شيء theoretical وبالconceptual part.
And probably I need to think that since you're not having the chance to do the experiment yourself, you're missing a lot of understanding. You know, لأنه sometimes in the lab when you try and it doesn't work, you would have the chance to think more about it. But when the results are given to you, you're missing a lot on this level. And I don't know how to do it, you know? But yes, I totally can hear you, Ramza, and I totally feel you have a point. Now for the final exam, let us wait until then and see what we can do, but we're not gonna make it unfair. Yani. For the midterm, I'm gonna see how I can modify the percentages, and my only constraint is we have to follow the other sections. Otherwise, it will be easier on us. So,
Doctor?
Yes.
Doctor, we can for the final exam, for example, to have more data analysis questions and conceptual questions. And Anna, I remember the MCQ part of the final of Lab Physics 1 was easier than this one. And you can feel after, if إذا بتذكر مظبوط, can feel after data analysis. You know, I think the problem was more in the subjective part, مش بال MCQ in last semester. But this time, لأنه there were many conceptual questions, it was more difficult for us. For example, the graphs في battery كان في مثلا سؤال عن resistance if it increases by a factor. I did not remember, بس إنه هيك كل القصص هول كانوا شوي ضياع لنا. But if we can have more data analysis next for the final exam.
Yeah, and less conceptual. Okay, I agree. Okay, listen, I need to move to lab 7, but I do believe that you want to talk more about the midterm. So how about you share your thoughts via email, because I really care about gathering all these thoughts together and share them with my team. Okay, so I don't want this to stop here. If you remember anything, like now conceptual questions and data analysis, this is the first time I hear that you had an issue with this. So basically, I was the students shared with me timing, backtracking, the fact that they were not focused, and many other reasons, but never discussed conceptual and data analysis related issue. Thank you for sharing with me. Anything else?
So, I was hoping I could raise just a certain concern regarding how the questions were like distributed for each person. Like I'd have a certain hard question which I'd spend 10 minutes on, for example, propagation of error. Let's say I had it as question number 17, for example, and I have 5 minutes. I can't afford to spend too much time on it.
Yes, so let me see if I got you right, George Michael. It's basically, you're saying that some students got this question at the beginning and some students got this question at the end, and it made a difference for you?
Yes, I believe the way the questions were distributed could have been more thought upon.
What do you suggest? We need to randomize the questions, you know? We cannot offer MCQ questions that are equal in difficulty. So we need to make them random, and which means that a difficult question or a long question could happen to be question number 2 for you, or question number 10 for Anthony, or question number 15 for Joe. So what do you suggest can be done in this issue? Maybe allow backtracking so you can skip it and do it later. Do you think this would be a solution for this issue?
Yes, I think backtracking is probably the best solution regarding في عالم their problem is إنه إجت بالأول, and others إنه إجت بالآخر وما عندهم وقت. So
and since you are not allowed to go back, so you had to do it. Okay, I totally feel you, and you have a point. So I will try to push for no backtracking for the final exam, and probably push for a better timing as well. Okay. Concerning
Dr. Sorry, one last thing concerning the total. Is it true that another section إنه كانوا على 200 نحن على 210, 21 questions وليك 20?
Let me be clear on this issue. One of the questions was cancelled for another section, and the question was so easy. It is related to precision and accuracy. And since I know that you guys are experts in precision and accuracy, I left it for you, and I thought it's good to keep it. Okay, so that's why some sections, they had their exam out of 200, into your exam out of 210, just because it was like one question was slightly different. Yes.
Oh, okay.
But listen, only one section out of the 5. So nihna, like everybody else, we were out of 210. Only one section was out of 200. عرفت كيف؟
Yes,
so
fine,
they were
yes.
different, we were common. Let me read Ryan. These chapters are quite the easiest as opposed to the coming ones. So I think everyone is concerned also about the final. All right, now concerning the P and the NP, when is the deadline to decide if you want it to be P or NP? I think the final exam is gonna happen before the deadline. I hope so. And I know that our final exam could be around December 4 or December 10. According to our syllabus, let me see, I have a picture in here, a quick screenshot of, what did I call it? List of experiments. It says, and I'm trying to follow the schedule, although I know it's impossible. Which one is your lab? This one. It says after December 4. So probably we're gonna miss this deadline, but let me tell you something. I have a feeling that LAU would change the deadline because this is what they did last year. They said end of November and then they moved it to December 8th. So I hope the final exam is gonna be earlier. Yeah, I think it's fair for the final exam to be before the deadline of the P and the NP. I don't know what to say. And yes, Ryan, I'm sure the coming experiments are more rich in conceptual challenge than the previous ones. And this is where I would say more data analysis will help you reduce the difficulty of the final exam. Okay? I also think if I offer more than 21 questions, this is good as well, because every question will be less in percent. Anthony, we already gave more percent on the lab report. It was 50%, it went up to 60. Do you mean like you want the lab reports to be greater than 60? Probably we can push a bit, but I'm not sure I can promise. All right? I think the best way to ensure pushing against the midterm is for you to do well in the final exam. If you do well in the final exam, this will give us enough reason to push down the midterm. You see? All right? Anyway, so since I cannot take any final decision right now, I'm gonna keep your concerns somewhere, probably saved on this file, and we can see what we can do. All right? I'm gonna add the P versus NP deadlines and final exam timing. If we can push the final exam to be earlier, probably this would help you. Earlier exam, let me write it here, earlier exam. This would be good for you, so you can tell. I know, Michelle, that pre-med students cannot have P and NP, and this is where I would want the final exam to be early to at least help the students who can go for P or NP and focus with the students who cannot. Yes, so Michelle is saying that pre-med students, the Physics 306 is a core course for them, and apparently they cannot opt for the P and the NP. Okay, yes. How about we can discuss the midterm later, because we don't have any timing happening right now. Like the grades I have here are official grades, yes, but they're still on my laptop. Nothing will be displayed officially on Blackboard. This will happen later in December. We can listen to you again. Of course, Ryan, I'm gonna listen to you. Imagine I'm not gonna listen to you. This is your course, and we're here only to advise you and to guide you. So, and to be as fair as possible to you. All right, now concerning lab 7, probably start with the video. So, yes, let me work in order. So I'm gonna fast forward what happened. And remember, you were supposed to start with a flat part of the mirror. And this is where you will have to draw the incident ray, the reflected ray, and the mirror, and then eventually draw the normal. And this is what I did with a pen on the white paper. Okay, so I flipped, I was explaining what the mirror looks like it has 3 different edges. Then I showed you how the light source actually function. You have 3 colored rays, you have a beam of 5 rays, you have a beam of 3 rays, and a beam of 1 ray. I used the 1 ray to be able to do reflection on a flat mirror. This is a reflection on a flat mirror. I drew the flat mirror. I drew the reflected ray. I used a ruler to be able to finish up the rays, and then I drew the normal, and I used the protractor to do the measurement for the angle of incidence and angle of reflection. Then I picked another position for my mirror, you know, 3 different positions to have 3 different trials for the angle. All right, that was for the flat mirror, and this is where my phone froze. And then for another video, but eventually I'm gonna stitch the 2 videos together, I'm showing what happens when I give a certain ray that is of 3 different colors. So there's a question in the lab report where they ask you what happens to the order of the different colors and if the angle will change. You do the observation well on the video, take your time to explain. Then I went back to 3 rays and to the concave part of the mirror, and I showed you the focal point. So you see a parallel beam or a cylindrical beam will reflect in such a way where you will have a converging beam and the rays will actually meet at one point. This is called the focal point, but we have to make sure that the rays are perpendicular to the surface to be able to discuss the primary focal point. So make sure you're not in a position that is like that, but in a position that is like that, just the rays to be perpendicular to the surface, and try to locate, okay, the focal point here. I'm locating it with a pen, and then I draw the surface of the mirror. Then I find the distance between F and the length of the surface of the mirror. Then here I'm drawing the surface of the mirror, elongating it as I move the mirror parallel to itself to be able to find the radius of curvature, and this is a bit tough. So either draw the whole circle that will be bigger than the paper probably, or try to use the method that is draw a chord, find the midpoint, draw a perpendicular, another chord, midpoint, draw a perpendicular for you to be able to find the center of your circle and eventually be able to measure the radius. Okay, so your job is to measure the radius. So you need the focal point and you need the radius, and I think you need to relate the radius and focal point. If I'm not mistaken, the radius is twice the focal point in theory. Now in practice, check them out and do the percentage difference. Here they want you to repeat the thing. What am I doing here? Okay, so they wanted you to repeat for a convex mirror and I did not, but probably I'm gonna share the values with you. Here I'm moving for the 3rd experiment where I need to do the experiment of refraction. So I created a small angle. I drew the surface of the glass. I drew the initial ray and the final ray. And I explained that this is the initial ray and this is the final ray, but this is not the refracted ray. This is incident and the refraction is happening inside. So what I don't know what's happening inside, I need to draw, extrapolate or interpolate. All right, now I can see what's happening inside. And now draw the normal and to be able to find the angle of incidence and the angle of refraction. Ignore what's happening outside the glass. And I'm gonna repeat this experiment for many different angles. You can see I'm changing the angle in here, you know, for many angles, and do 3 trials to be able to do, yeah. Now they want you to study the critical angle, no dispersion, because remember we had 4 mini experiments. For dispersion, you have to move your prism in such a way to start having some colors. And I know that what I can see with my eyes is a little bit different than what you can see on my smartphone. I tried to put my finger on purpose so you can see red and yellow, and I was seeing a very bright green, but it doesn't show on the camera. Please just write what you see on the video. I also tried to elevate the paper, so probably the green is a little bit visible, okay? So you cannot see 7 colors, definitely. You can barely see 3. So you can hear my voice saying green, yellow, and red. Okay. So I was rotating to show you the different colors. And I'm explaining that one will disappear. All right, and then I showed you what happens if I give an incident beam, blue, green, and red, and what happens to the order and to the angle of dispersion. Observe the video well to be able to tell. Now I'm doing total internal reflection. This is where you have incident and refracted. I'm gonna turn my prism in such a way for refraction to disappear. And I'm gonna do it so slowly because I want the refraction to be grazing the surface. This is grazing the surface because you can see some red happening in here. So it's still a bit visible, but reflection is happening internally. And when I remove my hand, you will see the reflected ray. Hopefully it's gonna be visible. Yes, you see? So this is refraction. This is reflection. Reflection is very intense because the refraction is disappearing. This is grazing the surface because you can only see red. So what you need to do here is draw the surface of the prism. Then you are supposed to locate this ray, and the intersection that is a bit visible on the other side. And when I remove the prism, you can see the rays and draw what's happening inside. And then when you draw what's happening inside, if you want, you can draw the normal and then show the angle of incidence, angle of reflection. Remember, this is theta critical and this is theta critical due to the fact that you still have a very mild refraction, so grazing the surface, so your angle of incidence is equivalent to the critical angle. So you will have two theta critical. Okay, so this is theta critical and this is another theta critical. So you end up with two theta critical. Okay, and here I'm showing you again the difference in the brightness. Look at the reflected ray. It's not bright, but as you go beyond theta critical, the brightness is gonna increase. You see how the brightness increases? So let me do it again. Look at this ray, low brightness, then bigger brightness, stronger brightness. Because whenever refraction disappears, all of the brightness will go into the reflected ray. You see? Yeah, and that's it for the experiment. Now for the third part of the experiment, I think that's it, right? We need to discuss lenses. So how about I start with our presentation for lab 8 and you guys get ready. It's a bit more difficult than, all right, then lab 7. Lab 7 was easier, but it's very quick because you only have 3 tiny experiments to cover. But before moving, I'm looking for which file, Jessie. This one? No. Did I remove the file? This one. We said that the lab 7 was due Wednesday. I want to push it for Thursday because I need the evening today to upload the video and the results. So it's okay to give you one extra day. It's gonna be Thursday evening. But again, you can submit anytime before Thursday evening. So when I say Thursday, it's not like I'm delaying you. I'm only giving extra time for only the students who need it. And lab 8 probably before next Monday evening. Because again, whenever you have the values, the lab report is so simple. You just have to make sure it's done. It's not like you have data analysis to do or any measurement to do. So how about we finish it next Monday, which means it's as if I gave you 2 weeks and a bit less for 2 experiments. I think it's fair enough. Any questions related to the deadlines and to lab 7 before we proceed? Please speak up.
Doctor?
Yes.
Can lab 8 be for Tuesday?
Of course it can.
Thank you.
Any other comment? All right, I'm ready for lab 8. Optics 2. So this is the outline. Experiment 1, we need to deal with convex and concave lenses. Experiment 2, let me call it mini experiment 2, Lensmaker's equation. I assume this is very important for your MCATs because I saw it in many questions. Question 3 is a trick offered to you that is called apparent depth that would help you find n, the index of refraction of a certain material. And you will be given 2 different experiments, like 2 different methods to be able to use the apparent depth to be able to find n of a certain material, okay? The first experiment is quite easy. Let me remove the chat box and let me keep this a bit away. So basically, this is the lab report part. They want you to find the focal length of a convex lens and the focal length of a concave lens. You will be given a convex lens and this is a concave lens. I know that in some books this is called converging and this is called diverging, but I know for a fact in the course they say convex and concave. Yes, so you will be given 5 beams or a beam of 5 rays parallel to the optical axis. They do converge to a point, and this is called the focal point of the converging lens. Yes, to be able to find the focal length, make sure you measure from O to F and not from the surface of the lens, which means when you draw the lens on your paper and you want to find the focal length, you're not supposed to be measuring from the surface. You're supposed to locate the center of the lens and do this measurement, and this is what I did. Now for the diverging lens or the concave lens, the rays do actually diverge in many directions. You're supposed to elongate on the other side of the lens and make sure they meet at point F, and then measure the distance from F to the center O of the lens. Okay? I will be showing you the procedure on the video and I will be giving you the measurements. And then this is a very interesting question. They want you to nest convex and concave lenses together. And they want you to observe what happens to the resulting ray going out of both, of the combination of both. And then they want you to slide the convex and concave apart and see what happens. And try to switch convex and concave. I did all that on the video very slowly for you to do a good observation. So just write what you observe and try to come up with a reasonable and easy conclusion. That's it for convex and concave. Probably before moving on, I can fast forward a bit and show you what I was talking about. So this is a convex lens. You can see the parallel beam of 3 rays, and then you can see how the beam is not parallel anymore, it's converging, and how I locate the focal points. But I was not being able to locate the focal point, so I located a big blurry area, and I took the midpoint just to minimize the errors. I called the midpoint F. Then I made sure to trace the lens and to measure the distance between the focal point and the center of the lens and not the surface. And that was the focal length. And I did the experiment again where I have a diverging lens and I actually drew the different rays. The rays do not meet. I make them meet on the other side. And I also explained that elongating the rays could be somehow an estimation, and this will induce a lot of human error. I also showed you that the 3 rays did not meet. This would happen sometimes for many reasons. Reason number 1, probably my elongation is not perfect. And I can see here a bit that I have a deviation. Now I can see it. Previously, I did not see it. I also believe that probably the initial rays, the 3 initial rays, I'm talking about those 3 initial rays, probably they were not perfectly parallel. That's why probably my rays do not meet at one point. But what happens in this case where I have 2 focal lengths, I'm gonna try to take the middle, the average, because usually when you have error on 2 things, it's like you have 2 trials and you find the average. And this is what I will do, but I will definitely repeat the experiment to have a better elongation and meet 2 points that are closer to each other. And then find the focal length, which is the distance between the midpoint, the middle of the lens, to the focal point F. Then I'm gonna change the paper to do something else. Here I have the two lenses together nested. So I'm gonna separate and you have to observe what happens. And then I'm gonna switch them and you tell me what happens. And I'm gonna slide them again and you observe and see what happens. Okay, now to move to the Lensmaker equation. Any thoughts about the Lensmaker equation? Have you ever heard of it? Did you do this part in the course or not yet? Yes, I'm listening to you. Did you do the Lensmaker equation or not yet? And have you ever did it in the course or heard of it? I'm waiting for your comments. Anyone?
I personally did the class last semester and I don't really remember this.
Okay, and I believe you did not try any attempt for the MCAT yet.
No, not yet.
Okay, by the way, when you finish the fall of 2020 and you start with the MCAT at some point, if you have any question, you are more than welcome to send me an email or to meet with me with any reason, because I know that MCAT has a lot of physics lab. And since I'm here, I can help you. And you can just keep in mind that I will be your instructor for many semesters if you need me. All right, now concerning the Lensmaker equation, F is the focal length that you just measured. So it's measured directly and you take it from the previous slide, okay? What is N? N is given, it's here. This is a screenshot of a procedure number 5. It says that N, the index of refraction for acrylic lenses is 1.5. So use that for N. Now your job is to measure the radius R1 and the measurement of radius R2. If you read the procedure, they want you to find the radius using simple reflection. In the video, I explained that I can easily draw this and make it longer and try to estimate the radius. They also say that it's not necessary to measure the curvature for both sides because R1 is equal to R2. They also say, remember that a concave surface has a negative radius, which means since you have R1 equals to R2, you will not end up with a 0 because of the difference, but take one of them to be negative. So in other words, you will be adding them, okay? Remember the Lensmaker equation is an approximation, and by approximation, it's an empirical equation given because of some experimental work. It's not like a theoretical equation to discuss, but it's very beneficial because it explains very well how you get the focal point. It's actually related to the material itself, which is N, and to the radius of curvature, because the greater the radius of curvature, the more diverging the beam will end up. And definitely this will affect the position of your focal point. You need to find the radius of curvature again. So either by drawing, or keep in mind that glass is reflective, and if you have some rays, you will end up with a very tiny reflection that you can see with the naked eye, and find F, which is the focal point of reflection and not refraction, and do twice this distance to find the radius. Do I make sense? So probably insert in text box in here and explain it again. To find R, you can do R is equal to 2 times F prime. I'm gonna call it FR. And what is FR? FR is, and let me keep it small FR. FR is the focal length of reflection, not of refraction. Not the lens. I'm not talking about the lens. I'm talking about the surface of the object. Let me repeat in a different way. This object that you call lens is actually a lens, and it's made of two reflective surfaces. If I look at a piece of glass, the window that is here next to me, I can see through it. So it acts like a lens. And I can also see a picture, an image of my face. So it acts like a mirror. So glass outside acts like a lens because it's see-through and like a mirror as well. R is the radius of curvature of the surface of the mirror. And FR is the focal length of reflection. So I can easily show you that reflection can happen. So this is in no mean the focal length of the lens, because the lens is the surface 1, surface 2, and the material inside. Okay? Anyway, I'm gonna give you the radius R1, and you're gonna find F using the Lensmaker equation calculated. So again, you calculate this one, using the Lensmaker equation and compare both. How do you calculate using the Lensmaker equation? How do you measure? You go back to the initial slide. My initial slide is this one. I can do the measurements to find F, and it's already in this table. Okay? So done with this part, I'm gonna repeat one for the converging concave lens and one for the convex lens. Any question for experiment 2? I need to hear from you, because probably I'm disconnected or probably you're away. I want to just feel that you are with me. Okay, thank you for your feedback. I'm gonna move to experiment 3, and you're gonna see that you have 2 slides. Apparent depth using the parallax method and apparent depth using the ray tracing method. The ray tracing method is so much easier. The parallax method, you need to use your eyes, and let me try my best to explain. Before I start, let me state that the depth, any deviation that happens for any ray as it goes through different media, will create a certain depth. Like this is the actual thickness. I'm gonna call this T, and T stands for thickness of the block of glass. D is the depth of the apparent image, because you know this ray will deviate as it goes away into the different medium, and you can see some deviation happening in here. And if you actually elongate both rays, they do meet at a point that is not the actual point. So I'm gonna call this object, and this is image. The object is the real object, and the image is a virtual reality happening because of the deviation. D is the depth of the image. How do I measure the depth of the image? I have 2 methods. Either ray trace it, which is very simple, or try to locate it with your eyes. And let me try to explain it really, because students have a difficulty understanding this method. And when you finish, you have to summarize everything in here. T is given. It's the same for both. D would be a bit different because they have both, they're both a certain estimated methods, but N is gonna be the same or a bit different. So probably find the average and discuss which method is closer to reality. I don't know, or more accurate, if you wanna call it more accurate. And probably you can discuss the precision as well. So let me explain how to do this method. You draw a line on a paper, an actual line, so you don't need a ray box. And you put the piece of glass or your trapezoid on top of this line. You will see the line and an image of a line, and you will feel that the image is closer to your eye. You will hold a very thin pencil or pen to try to estimate the position of the image. It's an estimation. Sorry, it's an estimation. You can see the line, you know it's a bit higher than the object, and you will try with the pencil to say, this is the position of the line. And you use both eyes to locate it. And then you close your left eye, then you close your right eye. And you see that the pencil is no more aligned with the position of the image. This says that your estimation is wrong. So you need to move a bit the position of the pencil, close the right eye, close the left eye. The position at which the alignment of the pencil is the same as the position of the image, this is where you would know that this is the real depth of the image. Okay? I don't know if you really got it, and then I cannot really show you what I actually see through a video, but I can show you how I'm locating the pencil. This is where you can find the depth. Now for this one, you will send 5 rays. This is the 5 rays I'm talking about, using a regular source of light. You use any obstacle to block 3 rays. You want 2 rays that are far away from each other. The 2 rays would go into the convex lens. They actually meet. You put your trapezoid on the meeting point, and you will see some emerging rays. You elongate the emerging rays on the other side of the trapezoid. They meet at a point that is not the real meeting point. So this is the real meeting point, and this is a meeting point deviated because of refraction from the glass. You measure D, the depth. You measure T, the thickness. You do the ratio to deduce N. Very simple. Now let me continue the video, and let me move the chat box a bit and probably put it in here because you need to keep the diagram probably for you. Okay. Here I'm showing you the ray tracing method. I blocked 3 rays, I kept 2. This is the lens. Now you can see the meeting point of the rays. Then I get the prism and I make sure to locate the prism at the meeting point, Then I get a pen, I draw the prism, I draw the rays, I remove everything, I locate where they meet. So this is the real point of intersection, and this is the apparent point of intersection because of the deviation of the rays. You see, the rays are supposed to go in this direction, but deviation happened because of the trapezoid. So you measure T, you measure D, and you can tell easily. All right, now this is the parallax method. I actually draw a line. I don't need the ray box. I put this on top, and you can see in the video that the line appears closer to the video, closer to the camera. It says that this is the image and not the object, and the image is higher than the object. So I'm showing you with and without. I use a pen to locate where the image is. Close my eye and open my eye again to be able to tell the location of my image. Okay? I also showed you that the location can be located with a pencil probably, and I can easily measure D. And T again is the whole thing. And I used a regular ruler using the centimeter to be able to do the measurement. It's not well focused, but you can hear me saying 1.15 probably, or 1.35. Does it show? I don't know. Anyway, it's gonna be visible from my voice. And that's it for both experiments. I don't know if you guys have questions. Please let me know. I'm gonna save as this file and call it section 1. So I can send you with the notations, although we didn't write much. So do you have any question? Otherwise, I'm dismissed. I'm done, and you guys are dismissed.
Dr. Sorry, but I have a question concerning the reports. There is drop de Delaware.
It says nothing in the syllabus, but probably we can do this later. I cannot confirm from now.
G.
Okay.
Because that semester there was.
Yes.
For this IR.
Yes. We sometimes do that, and probably if we need a push, we can do that for you as well.
Merci.
Anything else? Okay. Have a nice day, and let me know if you have any questions in the future.
Doctor?
Yes, Maria.
Doctor?
Concerning the resubmission of the certain lab reports, like if you want to improve our grade in something, can you submit it from like before, the ones before midterm?
Yes, you can always submit all the lab reports, and I promise I can go over them. I don't promise that I'm gonna correct the whole thing, but probably give you a bonus grade for your effort.
Okay.
Okay, so of course submit again. Always submit again. Why not? It helps you go over your mistakes. It's always beneficial for you. Somebody else had a question. Was it you, Joe? All right, let me know if you have anything. Bye for now.
Bye, doctor. Have a good day.
Bye.
Doctor?
Yes?
We